Guys, today we are going to deal with hexadecimal number system and the octal number system. And the octal number system, we are saying those numbers are with the base 8, and the hexadecimal number system are those numbers with base 16. I remember previously we covered all the numbers with base 2 and base 10. We said the numbers with base 2, they are called binary numbers, and we say they only include 0 and 1, which are called bits. Octal number system include all the numbers ranging between 0 and 7, and finally the hexagonal number system deals with all numbers ranging between 1 from 0 to 9, and A up to E. So it means uh, it they are where A represents 10 and B is 11, C is 12, and D is 13, E is 14, and F is 15. And we are going to see how they are converted to the required number. So like for example, we have several examples. Today I decided not to use the whiteboard due to some reasons, so just bear with me. I will just do the calculation, very simple, on a big book here. So just keep tuned, just follow me. You are told to convert the following binary number system, which is 357.321 into octal number system. And we said octal number system, they are the numbers with base 8, and they range between 0 and 7. So they are those numbers between 0 and 7. And what you normally do, you'll do just the same way that we did with the binary number system. So we have, it is 357.321, and this one is denary number, so it means it is to base 10. So what you normally do is to take 3, we are multiplying with 8. Remember, we are saying it is base 8. So 8, then you raise it to, what is the place value of 3? It is 100. So it means it is the place, its total value will have only 2 zeros. Then you also add to 5 multiplied by 8 power 1. I remember they are reducing powers of 8 plus 7 times 8 power 0. You are adding to 3 times 8 power negative 1 plus 2 times 8 power negative 2. And finally we add it to 1 times 8 power negative 3. So what you will get here, 8 squared, you are getting to 64 times 3, and you also add to 5 times 8, you also add it to 7. Remember, anything power 0 is 1, so it is like 7 times 1, which is just 7. You add it to 3 times 8 power negative 1, which means it's just the reciprocal of 8, and it will give us 3 over 8. You also added it to 2 times 8 power negative 2. So it is 2 times 1 over 8 squared, you are getting 64. It is 2 over 64, which is just 1 over that 2. This is the 1 over that 2. Plus we have 1 over 8 cubed, which is giving us 1 over 512. Remember, we have said that this one is giving us 192, plus this is 40, plus we are getting it is just 7, plus 3 over 8. Then plus this one, we see it is 1 over that 2 and 1 over 512. And this one on addition, when you add, you are getting it is 239, 209 over 512. So this one is the number that we are asked to look for. Remember, it is octal because it is of base 8. Similarly, if you are given another number like 524, then you are told to convert into octal number system. So what you will get here, remember there is no decimal point, so you can just approach another method. It will be 524, then you are dividing with 8, and you are getting it is 65. Then the remainder is written here, so you are getting to 65 or remainder 4. Then you divide 65 by 8, you are getting it is 8 because of 64. Then you remain with 1. Then you divide 8 by 8, you get it is just 1. Then the remainder is 0. Then if you divide this one by 8, it will just go by 0. It will just go by 0, and you remain with the 1. So we said you would take 524 divided by 8, you are getting to 65, remainder 4. You divide 65 by 8, you get it is 8 because of 64, remainder 1. You divide 8 with 8, you get that it will give us 1, then the remainder is 0. And if you divide this one by 8, you'll get it is this one will just go 0 times, and you remain with the same one that you had. So on writing the final answer, you will start from bottom upward. So it will just be 1014, and this is your final answer as required. So this is basically what is tested for you to get, and you have to get it correctly. Similarly, you may be given just a decimal point number like 0.1755. Let's just say this one, and it is a denary number, which means it's to base 10. Then you are told to convert into octal number system. So number system. So what do you normally do when you are given this instant? As we said with the binary number, you'll just take this, you multiply with, now that you are converting to an octal number, you will multiply by 8. Remember, it is to base 8. And you check whether your digits that you are getting as whole number here, they range between 0 and 7. Between 0 and 7. Not past 0, not past 7. Are we together? So that is what is basically tested. So let's check. It is 0.1755. You are multiplying with 8. So let's multiply. 40 carry 4, you get it is 40. 4 carry 4, 56. 8 times 7, it is 56. So it is 60 carry 6. 8 times 1, it is just 8 plus this one, you are getting it is 14. So carry 1. And remember, as you continue multiplying, the side with the whole number, you don't deal with it. So you just multiply the numbers past decimal point. So let's multiply with 8 again, and you are getting it is 8 times 0, it is just 0. 8 times 4, it is that 2. 2 carry 3, 3. So it is that 2, 2 again, carry this will just be 3. Remember, you don't deal with this. Again, multiply this with 8. Multiply with 8. This one you don't you will not add the 3 that you have carried. you'll just write it as 3. Remember, we don't deal with whole numbers, we deal with the decimal numbers. So the number on this side is the one that you deal with. Again, on multiplying again, it is 0. This one is 16, carry 1, 24, 25, 5 carry 2, 16, 17, 18. So it is 8, carry 1. Multiply again with 8. You don't add the 1 here where we have 3. So once again, I just want you to be very keen on that. And if the number is not terminating, let's just finish with this. It is 0, getting it is 8, carry 4, 40, 44, 4 carry 4. So this one is 64 plus 4, it is 68. So on writing, you will just write it is 0 point. We started here. So we have 1, 3, 1, 6. And remember, whatever we are getting, it is to base 8. And actually they are ranging between 0 and 7. I remember, no, there is no big number here beyond 7. Beyond 7, that is 8, 9, and so forth. So once again, this is how to calculate using the 3. The one with whole number, I think you have seen it. You use this approach. The one with which is mixed up with the whole numbers and again with these decimal points, then you use this other approach. And finally, if it is just a decimal number without a whole number, you use this approach. So once again, be very keen. Finally, as I had said, by the end of our today's class, we should be able to deal with the hexagonal number system. Under hexagonal number system, we are saying it has numbers ranging between 0 to 9 and letters ranging between A. Let's just write all of them. B, we have C, we have D, and finally we have E, representing. We have 10, 11, we have 12, 13, 14, and 15, respectively. Respectively. The word is respectively. So the way you are able to see them there, they are the same way they are represented. So once again, let's, for example, convert this hexagonal number into its octal number. So, for example, you are given 3C4 point 3F2. Then it is hexagonal number. It means it is to base 16. Convert into octal number system. So once again, I will take it is 3, then its place value is 100. So it means you will multiply with octal number. We said they are the number to base 8. So it will be 8 power 2. Remember, its place value is 100 and 100 has only 2 zeros. Multiplied by C represents 12. C represents 12. So it is 12. So we are adding 12 times 8 power 1 plus 4 times 8 power 0 plus 3 times 8 power negative 1 plus now F represents a 15. So times 8 power negative 2 plus lastly we are getting this 2 times 8 power negative 3. So once again, on adding this, the final answer that you'll get will be the answer that we need. So it will just be 64 times 3. Again, it is 192 plus 12 times 8. 12, we have 12 times 8 here, and you are getting it is 96. plus 4 times 8 power 0. So this 8 power 0, it means it is 1. Any number power 0 is 1. So it will just remain to be 4. 3 times 8 power negative 1, it is just 3 over 8 plus 15 over 64 plus 2 over 2 over 5 12, which is just 2 over 5 12 or 1 over 2 56. So let's add this and see what we are getting. Let's add this and see what we are getting. And we are getting it is 292.613 base 8. So this is basically what it is done. And let's convert another number. Let's do example 2. It will be also very simple. So let's convert this denary number 324.310. Let's say what? Let's use it when it is like 8. And this one is a denary number. It means it's to base 8 into hexadecimal number. So what we normally do, we'll just start from here. So it will be 3 times hexadecimal. We said it is to be 16 power 2. Remember it is hundreds. If you check on the place value, so 100, it normally have 2 zeros. And again, what you normally do, it is the decrease in powers of the 16. So power 1 plus, so it is addition, close your heart. So it will be 4 times 16 power 0 plus 3 times 16 power negative 1 plus 1 times 16 power negative 2 plus 8 times 16 power negative 3. So on adding this, or the final answer, like 16 squared, you are getting it is 256 times 3. You add it to 2 times 16 plus 4 times 16 power 0 plus this. What you will get will be your hexadecimal number that is required of you. So let me just use the calculator. On using calculator, I'm getting that 16 squared times 3, you are getting it is 768, as I've written here. We have 2 times 16, you are getting it is 32. We have 4 times 1, it is just 4. And remember, anything power 0 is just 1. And times 4, you get it is 4. So 3 times 3 over 16 plus this, then the final answer I got as 804.1934 base 16. So this is the hexadecimal number that you are required of. So once again, you have to be very keen on doing all this. There are many examples that I'm going to bring to you, so just be very keen. And I think today you have understood. Remember, we have learned from how to convert a denary number into octal number. First, we said a octal number. It is a number system which has its bits will be 0, 1, 2, 3, 4, 5, 6, and 7. And so 7 is the largest number that can be contained in an octal number system, and the 0 is the smallest. Once again, we said in hexadecimal numbers, we said it has all the numbers ranging between 0 to 9 and letters ranging between A and F, with A, B, C, D, E, and F representing 10, 11, 12, 13, 14, 15, respectively. The word is respectively. So the moment you are seeing an F somewhere, it means it was 15. If you are seeing 12, remember, if you are seeing C, then no, we are referring to 12. So you have to be very keen on these numbers and the letters that represent the hexadecimal number system. So just be very keen. To next time I will bring you more examples, so just keep tuned. Keep tuned. So this was for today. I think you have seen it very well and understood. So in case you have any questions, so just reach me through the comment section. I will be ready to answer. So if you like my video, then I'll just be very happy. In case you haven't pressed the subscribe button, do so, and God will bless you. Thank you.